Next, we having a question number 20. Question number 20 is, what is the meaning of the term enthalpy of ionization? If the heat of CH3COOH, this is acetic acid, with NaOH, that is a base, sodium hydroxide, reacts is minus 55.2 kilojoule per mole. As we know, when acid and base react together, they will form salt and water. The salt is CH3COONA and water H2O. This is the given information from the question. Calculate the enthalpy of ionization for acetic acid. You have to calculate the ionization enthalpy for acetic acid. So this is required. Ionization of the acetic acid, CH3COO negative ion plus S positive ion. When acetic acid ionized, it will give you acetate ion and hydrogen ion, means proton in a system. So how you can calculate the enthalpy change for this reaction by only this the given information of just one single equation. As you know, when strong acid like HCl plus NaOH react together, they will give you water plus salt, and the enthalpy change for strong acid and base is, we know that always it will be equals to minus 57.3 or 7.4. So 57.3 kilojoule per mole. We know this when strong acid and a strong base react, the enthalpy change always will be minus 57.3 kilojoules per mole. So basically what is happening in this reaction? H positive of acid plus OH negative of base are reacting together and making a 1 mole of water. Then this amount of energy will be released. So the basic equation is this one. Clear? And in a given equation, in a given information, this equation is basically CH3COOH plus OH negative of the base. That is the basic thing. When they react, they will give you CH3COO negative ion plus water. So by the help of these two equations, we know the enthalpy change for this equation, that is minus 57.3 kilojoule per mole, and the enthalpy change for this reaction is minus 55.2 kilojoule per mole. So if we subtract this second equation, subtract this equation 2 from this equation 1, no, the subtraction of this equation 1 from this equation 2, then we will get a required product. C, CH3COOH acetic acid plus OH negative hydroxyl ion from the sodium hydroxide. The product is CH3COO negative, means acetate ion plus water. Subtraction of equation number 1, that is H positive plus OH negative. Product is H2O. Enthalpy change for the first equation is minus 55.2 minus 57.3. You have to subtract this. So sign will be changed. Minus, 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 and this will be plus. Why I have chosen to be H positive ion as a minus? Because in a required equation, we need H positive ion on the product side. That's why I have chosen to subtract this equation. So when we are going to subtract Acetic acid is in a positive. This value is in a positive. So you have to write CH3COOH. These two will be cancel out because one is in a positive and other on the negative. And here positive water and the negative water. In a product, we have a positive CH3COO negative. This minus S positive ion will be moved on the other side of the equation. It will be H positive. So this is the basically a required equation. Enthalpy change will be minus plus minus. We have to subtract it, but the sign will be positive because the bigger value having a positive sign. So the answer is 2.1 kilojoule per mole. This extra amount of energy will be added in a reaction when you are neutralizing weak acid. Acetic acid is a weak acid and NaOH is a strong base. So when you are reacting weak acid with the strong base, then this amount of energy will be added in a system first to ionize this acetic acid. That's why there is the change of 2.1 kilojoule per mole of heat. Next problem is problem number 21. Part A of this reaction, this question is explain what is meant by the following terms. The terms are atomization energy and the second thing is lattice energy. So you have to just define or explain these terms. Third is draw a complete fully labeled bond-Haber cycle for the formation of potassium bromide. So for potassium bromide solid, you have to basically draw a complete labeled bond-Haber cycle. So let's do this. This is the part B of question number 21. Part A is a theoretical one, so you have to do it yourself. Part B, you have to make a bond-Haber cycle for KBr as we did for the NaCl, sodium chloride. So let's start. First, we are writing the heat of formation for KBr from its normal physical state. Potassium as a solid in a normal physical state and bromine as a liquid, bromine as a liquid in its normal physical state. So we need half molecule of this bromine. So heat of formation from their normal physical state to make a KBr solid is called as delta HF, heat of formation of KBr. Next is what we have to do. We have to change the solid into its gaseous atom. So change in enthalpy is enthalpy change for atomization of potassium. Then this potassium will be changed into potassium as a gaseous atom. Now you have to ionize this gaseous atom. So the enthalpy change is basically the ionization energy. So how you can change this? Ionization energy is basically the amount of energy that is required to convert a gaseous atom into its ion by removing electron from it. So if you are going to remove the electron from this gaseous potassium atom, you need ionization energy. So it will be changed into K positive as a gaseous atom. Clear? One electron will be released. Next, we having a bromine. What will happen with the bromine here? You can see this bromine should be converted into its atom. This is in a molecular form. So first we have to convert into its gaseous atom, then we are going to change it into its ion. So here I am writing, bromine molecule. First we have to convert it into its gaseous atom. So we need atomization energy. We have to make this atom. So atomization energy delta H AT, that is doing atomization. It will be changed into Br gas as a gaseous atom. Now we have to change this into a ion. So electron affinity is the amount of energy that is released from atom when you are going to add the electron. So enthalpy change of electron affinity. Bromine ion will be formed. So previously we having K positive. K positive will lose one electron. That one electron will be accepted by this bromine atom. And it will be Br minus. Now both of the gaseous atom will form solid KBr. The enthalpy change for this reaction is called as lattice energy. Enthalpy change for the lattice formation. This is the part B. We have drawn the labeled Born-Haber cycle for the formation of potassium bromide. Its C part is using the information given in the table below. You have to see in your books. Calculate the lattice energy of potassium bromide. So we have to calculate the lattice energy of potassium bromide. As we know how we can calculate the lattice energy, delta HL is equals to delta HF minus delta Hx. Delta Hx is basically the total heat change when the normal elements convert into its gaseous atom. These normal elements, those are forming KBr, will convert into its gaseous atom. That is basically all the heat changes for this conversion is basically delta Hx, represented as delta Hx. So let's start. In a table, values are given. You can see in a table. First, when you are forming KBr from potassium solid and bromine liquid, the enthalpy change is minus 392. When you are converting potassium solid into potassium as a gaseous atom, the atomization energy is plus 90. When you are ionizing, then the ionization energy that is added is plus 420. When you are converting bromine liquid, bromine molecule into a gaseous atom, then the atomization energy is plus 112. When you are converting this bromine gaseous atom into ion, the electron affinity, that energy will be released from the system is minus 342. So these all the enthalpy changes are given. By the help of these all enthalpy changes, you can calculate the lattice energy. So put these all values in a formula. Formula is delta HL. It will be equals to delta HF, the heat of the enthalpy change of formation, minus delta Hx, enthalpy change of all the heat content that is evolved in the conversion of element from their normal physical state to their gaseous atom. So delta HF is minus 392 minus, we have to add all the delta Hx. delta H1 plus delta H2. Delta H1 was the atomization of potassium. Delta H2 was the ionization energy of potassium as a gaseous atom, plus delta H3. Delta H3 is the atomization of bromine molecule, plus delta H4 is the change of enthalpy of electron affinity. So add all these values. The delta H1 was 90 plus 420 plus 112 minus 342. This will be in a minus because the value was of electron affinity, and electron affinity is basically the heat evolved from the atom when electron is added into it. So minus 392 minus, by adding or subtracting all these values, the answer will be minus, sorry, not minus with the plus 280. So plus minus will be minus. So minus 280, 392 minus. So minus will be plus. So this will be 672 kilojoule per mole. But sign will be minus because bigger value having a minus sign. So delta H is minus 672 kilojoule per mole. This amount of energy will be released. This amount of energy is the lattice energy when you are forming solid KBr, solid potassium bromide from their gaseous atom. This is the lattice energy, lattice formation energy.